It's a privilege and an honor to be with you here today to talk about the future of mobile software. I've been thinking about these ideas for a long time, and it feels good to finally share them with somebody. You see, over the last 9 years, I've had the privilege of being able to lead teams at companies that have either been working on building the mobile operating systems or looking to bring their products into the mobile platform. And having this vantage point has allowed me to identify certain gaps or areas that I think that we should be investing more heavily in order to make good on the promise of a mobile future. But before I go into those areas, let me first just set the stage as to where we are today when it comes to mobile technology and adoption. So here are some numbers that I really think paint the picture. The first number that I want to share, and probably the most impressive, is that the number of unique mobile users today is equal to 66% of the overall population of the world. That's great penetration. This statistic, this next one always makes me feel old, but it's true. iOS and Android are now 10 years old, and I've been working in that space all of those 10 years. And Facebook recently reported that half of its monthly active user base is coming from people who are using the service only from a mobile device. That's 1 billion people a month who are accessing Facebook using mobile devices. That's good news. Here's some more data that's interesting. In the past few years, we've seen companies that have either taken a mobile-only or mobile-first approach and been very successful in and of their own right. Companies like WhatsApp, Snapchat, and Instagram are examples. We've also seen web giants successfully make the pivot into being mobile-first companies, such as Twitter and Facebook, for example. It's also important to notice that with the dawn of devices either being on us or very near to our vicinity, we've been able to leverage what some people might call a digital Skinner box, but it's essentially the push notification system, which allows us to reach out and grab our users wherever they might be, to bring them back into our services, to get them to engage with our content and one another. This is a particularly powerful tool that we have with mobile devices that we never had before. And finally, it's important to notice that a lot of the content that's being generated on different platforms and networks is largely coming from mobile devices. Images, video, voice, for example, all being generated from mobile devices and then shared and proliferated across networks, creating great and engaging experiences for people. But what does that mean for us day to day? What does that mean for someone who's trying to use a mobile device today? Well, I'm going to give 2 examples and hopefully use them to outline the difference between where we are today and where we could be in a better mobile future. So here's the first example. I'm running late for my train. I see a train at the station. I wonder, is that the train that I'm supposed to get on? Or is that the train I always take and it's also running late? So I need some transit information. So I reach into my pocket and I pull out my mobile device. I go to Touch ID and the device says, phone restarted. You have to input your 6-digit passcode. I don't remember restarting the device, but fine, I'll try. I try to input my 6-digit passcode, but because I'm running, I obviously type a wrong number and it doesn't let me in. So I go to try again. I'm typing too fast. The OS has some lag. It's missed some numbers. I don't know which ones, but I delete all those and I try again. I'm finally in on my 3rd try. I go to the transit application. I launch it. I input the start location, which is the train stop that I'm at now, and I input the end location, which is the train stop I always take at this time of the morning on a weekday. It pulls up the summary information, and I try to read it while I'm running. The font's really small, so I stop. Sure enough, that's a train that I can get on. I look up, and the train is gone. Now, how could that have gone differently? I was looking at Pluralsight's Instagram feed last night, and I saw a post in there with an image that said, "What if?" So let's do that. Let's play what if. What if instead this happened? I'm running for the train. I go to Touch ID. The operating system would normally say, hey, the phone restarted. You need to input your 6-digit passcode. But the operating system knows that it updated itself overnight. And by using the accelerometer, it knows that I'm running and in a hurry, and I really need to get into my device. So this one time, it allows me access to a subset of transit applications, and maybe only transit applications that don't divulge any personal information. I pick the transit application that I'm looking for. already pre-populated is the start point because the GPS knows where I'm at, and the end point is the station I always stop at this time of day because it's built up some prediction on where I'm probably going to go because it's a weekday and it's 9 o'clock in the morning. It brings up a simplified UI in large readable font, and sure enough, I see that's my train, and I am on my way. I make my train. Here's another example. I'm commuting into work on a bus. I didn't get a seat this time, so I have to stand. Normally, I'd like to do a guided meditation during this time, but I don't have my headphones, so that's out of the picture. I decide I want to read my email instead, but because I'm moving around so much on the bus, it's really hard for me to read the small text, and it's making me a little bit motion sick. So I decide the next best thing that I want to do is browse beautiful images on Instagram. So I go to launch the application, and this is what I see. Has anyone ever seen this before? Anyone know what happened here? I launched the application when there was no network connectivity. I must have gone into a dead zone on this bus route. And so because there was no network connection, I wasn't able to pull down any data for my feed. And for some reason, Instagram has decided that none of the other feeds are relevant offline. The only feed that's interesting is the main feed. And the data that's there is only the data from the last time I manually pulled to refresh in that view. No data is ambiently coming down to me in the background, for example. So let's play what if again. How could that have gone differently? I'm standing on the bus. Because I'm moving around and the phone has an accelerometer on it, it knows that reading will not be a good experience. So it doesn't try to predict any sort of reading applications for me at this time. It also knows, using the microphone, that I'm in a really loud environment, and there's no headphones either plugged into the jack or paired via Bluetooth, and so it doesn't try to recommend any media applications at this time. What it does instead is it decides that what I'll probably want to do is browse beautiful images in my favorite applications, and so it wakes them up and optimistically starts pulling down images for me to be able to view offline. Maybe just enough to get through the dead zone, because maybe the OS can make a query to understand what the connectivity map is on this route. Then my commute is saved. I encourage you to, in your daily life, start thinking about these deltas and gaps. What would be a great user experience, and what are you seeing as a contrary to that? Let's write them down, and let's keep ourselves honest, because what we really want to have is these mobile devices that are enhancing and enriching our daily lives in deep and meaningful ways. And I think we have a long way to go. And after seeing iOS 11, I'm worried that we might be headed in the wrong direction. So how are we going to do better? Well, apps and operating systems are going to have to be smarter if we're going to really want to make people's lives better. And let's talk about how we're going to do that. So I mentioned on the bus example that I could drive into a dead zone and not be able to get any connectivity. And this can happen when you walk into an elevator, drive into a car park, or go into a tunnel. But for the majority of people who live in rural areas, this is a fact of life. They might have no or very limited connectivity. And why is that a problem? Well, it's a problem because if your service relies on streaming media or very rich content, your service could be completely unusable in these areas. If we think about international markets, devices in these regions could be really underpowered and memory constrained. They could be running older operating systems, which means that we need to get any sort of optimizations into the OS today if we want them to proliferate so that everyone can benefit. So how are we going to do better when it comes to this low connectivity challenge? Well, apps and operating systems are going to have to be smarter. And I think we're going to have to honor that bandwidth that we're using and honor that limited time of connectivity by having the apps and operating systems steering the user experience and stop requiring users to have to do so much driving. So what I mean by that is that we can start to try to predict the intention that a user had. What were they trying to do when they reached for their device just then? In the train example that I gave, I was running and I was at a transit location, so the OS knows that I needed some transit information. In the bus example, it was using predictive techniques to know that reading wasn't going to be a good experience, media wasn't going to be a good experience, and so I'd most likely want to browse some images. Now, I just want to mention here that I've been thinking about this for 5 years. I filed this patent 5 years ago when I was at Apple called the Adaptive Operating System. And the idea is that the OS would start to use the ambient sensors on the device to reason about the environment that the user was in, and then start to predict what would be the best experiences given those environments. Here's an example of when intention can go completely awry. I don't know how many people saw this, but a few weeks ago, there was a hurricane, and the OS surfaced 2 emergency alerts that said there's severe weather conditions in your area, stay inside. And then shortly after that, Pokemon Go says, hey, there's new Pokemon in your area, why don't you go outside and catch them? And I really like this guy's comment on that. But you know, the OS could have done better. It knew that it surfaced those alerts, and it knows that Pokemon Go is an application that uses the GPS and maybe even encourages people to get outside. It could have, in those regions, maybe suppressed that push notification. Or better yet, it could have given a notification to the Pokemon Go developers that says, hey, I've issued some severe weather alerts in these regions. Fold that logic into your push notification algorithm so that you could decide whether or not you really want to encourage people to get outside right now. With that small optimization, we could not only make someone's day better, but maybe even save their life. So once we know what a user will likely do with their phone, what we need to know is what content they're going to need to do it. So in the Instagram example that I gave, I'm going to need some images. And now I'm not suggesting that we should open all of the things and pull down all of the data, because that would eat up people's bandwidth and fill up their hard drive. What I'm suggesting is that we start to use more of a progressive download approach, where we start to think about what is the footprint that a user is going to take throughout the application, and start to pull in data for that pathway. This is a lot like how we load games today, where we load them level by level. See, Apple hinted at this when they made available the progressive asset downloads, that we don't need to have these gigantic binaries coming down anymore. And just so you know, gigantic binaries in regions of low connectivity is going to be a real problem. So think about what content is needed for these offline experiences, and try to optimistically pull that content down. It's interesting because if you look at some data usage patterns for applications, if you look at what areas people are going to, they're normally just visiting a fraction of your application. So there isn't really that much data that I'm talking about. It's just the really most relevant data. Now, once we have the data, we're obviously going to need to develop some advanced caching strategies. And I know caching strategies are hard when it comes to offline context. Normally, people do use things like least recently used tags to determine what they need to purge. But what I'm encouraging is that people start to think about tagging or weighting their items with things that are relevant to the user experience. So for example, if I was developing a group chat application and I wanted to allow offline browsing of the transcript, saving the user information like their avatar and their name, for example, is really, really relevant, because who said what in a transcript could make all the difference in your understanding of that conversation. Another strategy I think we can start to employ is that of cooperative downloading, so sharing the bandwidth burden. And this becomes particularly important in regions of low connectivity. This is also known as peer-to-peer device networking or mesh networking. And I think there's really use cases for this even today. Here's another example. So my friend Chikezi likes to go camping. And at some point when he gets into the Sierras, he's going to start to lose connectivity. Now, if his Nest Protect wants to let him know that there's smoke in his house, and if he's out of connectivity range, the only time he's going to get that notification is when he comes back. But what if, optionally, Nest Protect owners opted in on any platform to relay this message to one another to try their best effort to reach him before he's completely gone? Now, there's no guarantee that we're going to get him. There's no guarantee that there'll be someone in peer-to-peer range. But it certainly is better that we try than just send one notification and blindly wait for him to come back. Now, once we have predicted what the users are going to do and we have the data that they're going to need to do it, the next thing that we want to do is surface just the right user interface. So in that example that I gave for the train, a user interface came up with pre-populated data and big readable font. That's a lightweight interaction. And I want to contrast that with some of the user interfaces that we have today, which are largely ports of very complicated web UI that have been shoehorned into a smaller form factor. We see mobile devices or mobile applications today that have hamburger menus on the left, which when open have 10 different options, and more options on the right, which when you open slide to have many more options on the other side. And if you look at the usage patterns, oftentimes people aren't visiting really much of the application. If you talk to your customer service representatives, they'll tell you story after story where they had to tell someone that a feature was in the application because they had no idea, because they don't even use those. And yet we have developers that are supporting and fixing bugs in these areas of the code. We have customer service reps who are writing documentation for these parts of the application that are largely unused. And what's worse is that oftentimes these applications require users to do a lot of work to navigate to where they want to be. And if they leave the application and come back, oftentimes that navigation is reset, either because the application was killed in the background or because no one cared to save that hard work that the user did. By and large, these applications are also very homogeneous, meaning that the UI that I see is the same UI that my husband sees, is the same UI that my mom sees, even though we use the same application very, very differently. So how could we do better in the context of lightweight interactions? Well, I think as product owners, we're going to have to think long and hard about what those really most important experiences are and serve those up first and make input very, very simple. Remember, we're trying to make the most of that limited bandwidth time that we have, that users have. And so in that regard, we don't want to waste time navigating. We want to do a lot of the reasoning and work for them. So how can we do this? Well, as product owners, we should recognize that form factors have changed and will continue to change. We should be ruthless about cutting features that don't make sense on any given platform, and maybe invent some features that only make sense on a subset of platforms. And one way that we can do that is by understanding the usage pattern on the different devices. For example, on a watch, a device or a typical session could be about 3 seconds long, whereas on a tablet, a session could be up to an hour. So think about your product and how it might be able to span such a diverse amount of time. And also think about what features do and do not make sense in that bursty pattern of time as well. Also, and something that I'm very much looking forward to, is that inputs are changing on these mobile devices. People are starting to use the camera to drive image search. People are starting to use voice to input into fields. The more that we can move away from having to use these keyboards on these devices, the better for me, because frankly, they're not very pleasant. Now, where is this all headed? Once we can start to predict what people are going to want to do with their devices, once we're able to surface these great user interfaces that are predicting what people are interested in, this is obviously lending itself to augmented reality. Now, I'm going to say here that augmented reality is almost here, and I'll explain what I mean by that in a second. So let's just talk about where we are today. Well, it's frankly somewhat new in that Apple just released its interface guidelines to instruct people on best practices when it comes to the UI of AR applications. AR Core and AR Kit were recently just released for developers to play with. And as of today, Pokemon Go is still really the killer app. Even though it didn't even use the camera, it mostly just used the GPS. But it did open the door and get people comfortable with the idea of walking around with a device in their hands. So how are we going to make these AR applications fulfill that promise that mobile devices originally were, which were digital assistants that were giving us just the information that we needed? Well, AR applications are going to have to be powered by engines. They're going to have to filter through mountains of data and do a lot of the heavy lifting for us when it comes to getting that information that we want and personalizing it to what our interests are going to be. And so the way that we're going to do that is by developing engines that can reason about the scenes that they're in, turn that rationale into maybe objects or queries that can go out into the internet, and then filter the results that come back in a very personalized fashion. And I don't want to have the results that come back be just a Google search results list that I have to scroll and click through in order to find the information. I want just the right information to be pushed to me. I want to stop having to pull data from the internet. So here's some examples. I open my AR application. I'm in the kitchen. There's some tomatoes, some onions, and maybe some other vegetables on the counter. And it reasons that I'm probably about to cook soup, because I'm always cooking soup. It goes to the internet, and it finds a soup recipe that it thinks I might enjoy, and it overlays it on the AR application for me. Now, I just want to mention that this data exists. There are websites today like Supercook where you can input the ingredients into a recipe, and it'll tell you what you can make out of those ingredients. What's missing is that engine that can reason about the objects in the scene, turn that rationale into the search query, and then bring those queries back to me. Here's another example. So I opened my AR application in a state park. I pointed at the sign, and because it knows I like to take long hikes, it points me in the direction of a trailhead that's going to take me on a nice long hike. Again, this data exists today. This is the All Trails website, where you can input a start location, a duration of a hike that you want to take, and maybe some other attributes, like do you like to have a good view, do you like to be near water, etc., and it'll input the best hike for you. So once AR applications start doing the heavy lifting of going out into the internet, finding the information that's relevant to you and presenting it in a beautiful way, these AR engines are going to start being our cognitive sidecars. Now, I've talked a lot about using our sensors and developing personalization algorithms that are learning about our interests and personalities. And so it's important for me to note that security is going to have to work if we're going to hand over this much of our personal information to the devices. So let's talk a little bit about where we are today when it comes to security. Well, believe it or not, passcodes are optional on our devices. It's pretty crazy if you think about it, but it's true. And once people have opted into the idea of locking down their device, there are some more advanced authentication mechanisms like Touch ID and Face ID. But if you think about the data that we have on our phone, it's kind of chilling when you think about the fact that people could optionally set a passcode. We have our credit card information, our banking information. We have who we're talking to and what we're talking about. And we're willingly handing over third-party data to applications that talk about our fertility, our diet, our activity, and even our mental health in some examples. We also have our personality information, like our browser history, our social network activity, even our recently used emoji, words, and search terms are all on our devices. So how are we going to do better? Well, apps and operating systems are going to have to be smarter. As developers, we're going to have to hold ourselves to a really high standard to really be stewards of this personal information. And we're also going to have to lean on our operating system developers to give us the hooks to be able to make the best decisions when we're writing this really personal data. In the future, we're going to be storing way more information that's personal, about our identity even. Things like passport and driver's license could one day live on our phones. And whatever these sort of personalization algorithms, if they input some sort of file format, that could be on our phones. And one day there might even be voting records. So here are some things we can do today. Well, for one, we can ask OS developers to give us a callback, to let us know if we're about to write personal information on a device that's been rooted, because those devices could have vulnerabilities. Or we could ask the OS developers to give us a callback if we're about to write personal data on a phone that has no passcode set. That way, as developers, we could require an app-level passcode if the user refuses to have a device-level passcode set on their phone. And as developers, we should always opt into the highest level of security encryption when we're writing these personal files. For example, on iOS, every project can opt into encryption at rest. It's default off option right now. Perhaps it should be default on. But what this allows us to do is to use the operating system's encryption of these files when a passcode has been set on the device. And there's other levels of encryption that we can suggest for everything that we write. I suggest that we use the highest levels possible and use the low level only very sparingly. So I hope by now that I've convinced you that apps and operating systems are going to have to be smarter if we're going to make good on that mobile future. And I also hope that I've convinced you that by doing this, we can make people's daily lives a little bit better. And because the majority of people are using mobile devices, then by definition, we can make the world a bit better. And I hope you want to do that with me. Thank you very much for your attention.